Hello friends, welcome to this video. So after long I'm back on this channel. थोड़ा busy था और इस नवंबर के बाद I will be regular on this SY BSc portion and TY BSc portion also. But अभी के लिए lecture number 1 को start करता. तो आज जो हम लोग start करेंगे that is something but the finite sets. डेफिनेटली आज भी कुछ थ्योरम स्टार्ट नहीं कर पाएंगे लेकिन फाइनाइट सेट के बारे में बहुत सारी जानकारी मिलेगी आज. सो फाइनाइट सेट्स जो होता है व्हाट आर द फाइनाइट सेट्स. You can give me hundreds of examples. Let me write just 2 examples over here. So it is 1 2 dot 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 dot, dot 10, suppose 10 millions. Is it a finite set? Yes, because I can count the element and I know where it is ending. Correct? Okay. Similarly, you can give me some example like 2 3 5. This is also a finite set. 100 of examples you guys know. Correct? But how the way we defined a finite set inside our mathematics? Correct? So question is this phi is a finite set? Yes or no? For this we need a proper definition which will tell us which sets are finite and which sets are not. Okay, so let's move on to the topic. Okay, so over here we start with a notation. पहले जो हम लोग करेंगे that is nothing but notation. Notation क्या है? Notation जो हमें चाहिए that is nothing but this n m. What does represent? This n we use for natural numbers and this small m represent we consider first m natural numbers. That means this is nothing but the set 1, 2, 3 till m. Correct? So this represent first m natural number. ओके सो ये नोटेशन हम लोग बार बार यूज करेंगे सो प्लीज राइट इट डाउन. ओके सो दिस आफ्टर दिस नोटेशन I want to give you some note, but before that also we need some definitions. Let me just give you the definitions. Okay, so well defined function in this entire portion will be using this idea of well defined, 1 1 and on to. So this is my habit when I used to study. I used to write all the definition which will be required for the chapter at the first page of the chapter. So I'm making you guys also do the same thing. So what is the definition of a well-defined function? A map is said to be a well-defined map from A to B. A map F is said to be well-defined from A to B if whenever x is same as y, then that should imply my f of x is same as f of y. What is the meaning of this? You guys have learned this many times, but what is the meaning of this? This says that if I have the same point, then their image is also same. It is not possible that the same point goes to two different images. That means my map should not be one to many. It should not be one to many. How I remember, it should not be ohm. Correct? If any map is ohm, it is not well defined. From one to many, then it is not well defined. Okay, it could be many to one. It might be possible 2 or more points are going to the same image. Okay, that is possible, but it should not be ohm. That is 1 to many is not a well defined map. After that there comes a 1 1 map. So how I remember 1 1 map is nothing but this is a converse of well defined. Means over here we say x equal to y implies f of x equal to f of y. In 1 1 we remember it as f of x equal to f of y implies x equal to y. This means what? If 2 points have the same image, that means if I want to represent it diagrammatically, let me just try to represent. Okay, let me just go down. Okay, this means if I have what I want to prove is f of x equal to f of y implies my x equal to y. Okay, what is f of x and f of y? These are nothing but points in my codomain. Over here I have a domain x and y. Over here I have f of x and f of y. If my f of x equal to f of y, correct, then if this is x and y, that this two must be same. Means if the map is like this, if the map is many to one, then those 2 points must be the same point. Correct? It is obvious because if my x is not equal to y, then I have 2 different points which are going to the same image, means my map is many to one, which we don't want, right? So what are 1 1 map? 1 1 map are only those map which are not many to one. Correct? So it's just a simple definition. A 1 1 map is a map which is not many to one. Okay? So after that we have an onto map. Onto map is really simple. Onto means every point in a codomain has a pre-image. Means what? every point inside B there exists x inside A such that my f of x equal to y. These things are really trivial, but you should write this. Also inside an homework you guys will write 2 example for each, means 2 example of well defined, 2 example of 1-1 map, 2 example of onto map. So this will help you to understand the idea in really better way. Also writing this examples, last which I wrote, that means write 2 example of each which are not. Write 2 examples of a map which are not well defined. Write 2 example of map which are not 1-1. Write 2 example of map which are not onto. So you have a free degree of freedom. जहाँ पर भी सोचना है, in whichever dimension you guys can think, and write 2 example in each of these cases. Okay. Now we come to our note, which is really important. Okay. Why I am telling this right now? Because this is something which I learned or I understood really better when I was preparing for a competitive exam. But it is some really simple thing. The idea is from more to less, there is no 1-1 function. What I want to say in this is, if I have a if I have a map from f from A to B, if my cardinality of A is greater than cardinality of B, then from A to B there cannot be any 1-1 map. This idea is really simple, but on the simple idea, thousands of different examples and thousands of different questions can be created for the competitive exams. Okay, so this says is, if I have a map, suppose I have a 5 element in the domain and the 3 element in the codomain, then from this to this there cannot be any 1-to-1 map. Suppose if I try to make a 1-to-1 map, so it is like this. This will get map over here, this will get map over here. These 2 points will be left, correct? So from A to B there won't be any 1-1 map, but if I restrict my map on this 2 element, these 3 elements, then there will be 1-1 map. This is the further idea, not required right now. But from more to less there is no 1-1 function. Okay, this idea need to be proved by us, but I am giving you guys as a note, because proving it is just by using induction. Okay, so if someone want, they can prove from more to less there is no 1-1 function. Okay, so similarly student can note or can think of the next result, that is from less to more there is no onto function. From over here I consider 3 points, over here I consider 5 points. If I am trying to make an onto map, onto means what? Every point has a pre-image, correct? For this the pre-image is this. For the this, can the pre-image be this? Yes, the pre-image can be the same element or not. That is a question mark, right? Can it be? If suppose this 2 point has the same pre-image, then this function become 1-to-many, which is not well defined, right? So if the function is not well defined, we don't talk about 1-1 and onto. So we know that this thing cannot be possible. So this second map should be like this, correct? It should go to some different point. Also this should go to the third point, and this 3 point will be left. So from less to more there is no onto map. Clearly this thing you cannot write in an exam, but you can understand the idea and try to prove this by using induction, correct? If you guys get stuck somewhere, if you are not able to find out in any reference book or anything, you need an help, just write in the comment box. I will prove this idea. It's really trivial actually. Okay, but this two notes should be written inside your book, and you should understand the idea first. Okay, I think after this we should go to the third page. I hope every student will write these things and write the homework question for the next homework for the next video. Okay, so now we came finally to the finite set. Let us define what is the meaning of a finite set. Before that, we'll need what is the meaning of a cardinality. You guys already know what the cardinality is, but let us define it mathematically. Okay, so a set S is said to have a cardinality M if and only if there exists a map F from S to NM. This S is nothing but this set, and this NM is nothing but set of first M natural numbers, a map from S to NM, which is what it should be, which is bijective. Okay, So this idea is really simple, but it is used thousands of times inside the degree only, correct? So how do you do this? So if you want to prove some set has a cardinality 10, what you will show? You will show that it has a bijective map with another set which has a cardinality 10, or you will show it as a bijective map with n10, correct? Okay, now the notation of the cardinality is this, you guys already know, so you should write the cardinality. This means this is defined as cardinality of S, that is same as number of elements inside set S. This is notation which I use for numbers of element. Okay, so this is nothing but what is the meaning of a cardinality? A cardinality is M if and only if there exists a bijective map from S to NM, correct? Simple. So finally a finite set. Okay, a finite set, a set S is said to be finite if it is either an empty set, correct? If it is an empty set, then also it is finite, or the cardinality of A is some natural number n. Whenever I say the cardinality is n, that means what? That means there exists a bijective map with nm for some n inside a natural numbers, correct? So if you tell me 10 million, 10 billion, anything, if you can tell me that number, then that set will be a finite set. Okay, so after this, what is the meaning of an infinite set? So infinite set is nothing but a set which is not finite, that is called as an infinite set. Means what? Let us just try to define this mathematically. A set M is infinite if and only if there does not exist any bijective map f from M to n m for all m inside natural numbers. Means an infinite set cannot have any kind of an bijection with set of first m natural number, and this is true for all m inside n, correct? So sorry. So in this video we learn definition of a finite set and definition of an infinite set. In the next video we'll be working on some results, some theorems on a finite sets. Okay, for any doubt and difficulty, write in the comment box. And thank you guys for watching this video. Please share it with your friend. If you are not subscribed to my channel, please subscribe to it. Like, share and subscribe, and bye bye.